Good day everyone. Today we will solve a problem on Fluid Mechanics Chapter 6, Fluid Flow Measurement. In this chapter we will calculate a property of fluid that involves the use of measurement devices, and we have different devices in this chapter, but in this problem we will use an orifice as a device. And all of the equations in this chapter is mainly based on the Bernoulli's energy theorem. Let's start. A cylindrical tank having an inner diameter of 2.5 meter and a height of 4 meter is full of water. An orifice with a diameter of 0.15 meters is located at the bottommost part of the side of the tank. Determine the time it requires to lower the surface level of the water into half if the discharge coefficient is 0.6. So here in our figure, we have the height of the tank 4 meters, and this is the level of the water. The tank is full of water, and this is the diameter of the tank. We also have the diameter of the orifice, which is 0.15 meters, and the discharge coefficient of 0.6. So we need to write all the givens we have. We have h sub 1 is 4 meters. This is the initial height of the level of the surface of the water, and we have h sub 2 is equal to 2 meters. H sub 2 is 2 meters because we are asked to, we will lower the level of the surface of the water into half. So the initial level is 4 meters, so we will divide it by 2. So because we are required to lower the level of the water into half, so 4 divided by 2 is 2. We also have the value of the coefficient of discharge, which is 0.6, and the diameter of the tank, which is 2.5, and we have the diameter of the orifice, which is 0.15 meters. So for the solution, since we are dealing with a tank that has a constant cross-sectional area throughout, we will use this equation to solve for the time. And we have 2 times the area of the tank multiplied to the difference of the square root of h1 and h2 all over the coefficient of discharge multiplied to the cross-sectional area of the orifice times the square root of 2g. We have the value, we have a given value of h sub 1 here. We also have a given value of h sub 2. The gravity is constant. But we don't have the value of area of the tank and area of the orifice. But we can solve it because we have a given diameter. So for the area of the tank, we have pi d squared, and the diameter is 2.5. So simplifying this, we have the area of the tank, which is 4.909 meters squared. And now we will solve the area of the cross-sectional area of the orifice, which has a diameter of 0.15 meters squared. And simplifying this, we have area of the orifice is equal to 0.018 meters squared. So now that we have the values for all of the variables in the equation, we will plug in all these values to solve for the time. So for the area of the tank, we have 4.909, h sub 1 is 4, h sub 2 is 2, coefficient of discharge is 0.6, area of the orifice is 0.018, and the gravitational acceleration of 2.81. And simplifying this using a calculator, we have the value of time of 120.22 seconds. So this is the final answer for our problem.